All right, so let's go ahead and start off with talking about our isomers. Okay, I will tell you guys what are isomers, and after I tell you guys what isomers are, I'll first go over some rules about related to. Okay, first we'll discuss isomers, and then I'll go over the rules you need to know about naming an organic compound. Okay, so let's first talk about isomers. Isomers are compounds that have the same molecular formula but different structural formula. Let me explain this, okay? Viraj, to you, this statement might make some sense, but I'm still going to go it in a bit of detail for Shreya, okay? Now, so when we talk about any organic compound, okay? That organic compound, so for example, let's say we have an organic compound that has a formula C3H8. Okay. Now, this is known as the molecular formula. Okay. This is known as a molecular formula. Molecular formula simply tells you the number of elements inside a molecule. So in this molecule, we have 3 carbon atoms and 8 hydrogen atoms. Okay. So this is the molecular formula. The molecular formula tells you the number of atoms, the number of different atoms inside the molecule. Okay. Now, I can take this molecule and I can draw it, right? I can show the bonding. So we have 3 carbon atoms, 1, 2, 3. And then we have 8 hydrogen atoms. So 1, 2, 3, 4, 5, 6, 7, 8. This formula is known as the structural formula. A structural formula shows you the which atom is bonded to which atom. It's one thing for me to tell you guys that, okay, in this molecule, there are 3 carbon atoms and 8 hydrogen atoms, right? That's one piece of information. Now, how is the bonding? Are the carbon atoms bonded to each other? Are they bonded to the hydrogen atoms? What is the structure? What does it actually look like? Who is bonded to who? Are the hydrogen atoms bonded to each other? Are the carbon atoms bonded to each other? What does it look like? So when I take the molecule and I draw the structure, I show the bonding. I show that the carbon are attached to each other. I show that the carbon and hydrogen are bonded to each other. I am telling you the exact structure. I'm telling you who is bonded with who. That is known as the structure formula. Okay? Now, isomers are compounds that have the same molecular formula but different structural formula. Let me give you an example. An easy example that I can give you is, let's take a molecule which is known as C4H10. Okay. Now, I can take this molecule C4H10 and I can draw it in 2 ways. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is one way of drawing the same number of atoms, carbon atoms, same number of hydrogen atoms, right? Nothing changed. I can draw this in another way. 1, 2, 3, 4. See, 4 carbon atoms. And again, we'll draw 10 hydrogen, just like we discussed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Both of them have got 4 number of carbon atoms. Both of them have got 10 hydrogen. But if you look at the structure has now changed. So both of these molecules are isomers of each other. That's what an isomer means. that they will have the same molecular formula, but they will have a different structural formula. That's an isomer. Okay, by molecular formula, we mean that they will have the same number of carbon atoms, same number of hydrogen atoms, both of them. Or I'm using a simple molecule in organic chemistry. You will study about, your alkenes, alcohols have got oxygen in them. Carboxylic acids, they also have oxygen in them. You have got organic compounds that have nitrogen, that have sulfur. You'll not be studying them, but you do have organic compounds that have nitrogen and sulfur, right? The main important thing is that the number of atoms remain the same, but the structure becomes different. So we will say that these two molecules are isomers of each other because they both have the same number of carbons, same number of hydrogen, but the structure is different. Right? Making sense so far? Shreya, is this making sense, Viraj?
Yeah.
Yeah.
Okay. Now, when we talk, this is something that often in the past, when you guys practice past paper questions, I'll be practicing questions with you guys. So when we solve past papers, you guys will see that they give this quite a lot. They'll give you like any compound and they will say draw isomers of it. Or they'll give you any compound and they will say identify the isomers. So you'll have like 4 or 5 structures that are drawn in front of you. You guys have to identify. So let's go ahead and see how can you draw the different type of isomers. Okay, now when we talk about isomers can be classified into 2 categories. Okay, isomers can be classified into 2 categories. One type of category that we have is known as structural isomers. This is the one that you guys are studying with me right now. Okay, the ones that I am teaching you guys are structural isomers. Then there's another type of them which is known as geometric isomers. You guys will not be studying about geometric isomers this year. You guys will study about them inshallah next year in your A-levels. Okay. So this year you guys are not dealing with geometric isomers. We'll be studying about structural isomers. Now, in structural isomers, there are 3 possible ways of isomerism. One type that we have, and I will explain all of these one by one, is chain isomerism. We can have chain isomers. Okay. We can have positional isomer. And we can have functional isomers. Now, functional isomers, I will explain what they are, but you're not going to be dealing with them too much. Okay, you will mostly be dealing with chain isomers and positional isomers. Let's go over this. Okay, let me go ahead and put in front of you guys an organic compound. Let's say we have a compound that looks something like this. Okay, so let's draw. This is the compound that I've given you guys. Number 1. Let's draw as many isomers as we can think of. Okay, so we will first isomers, we can just draw it like a straight chain. Okay, the first option is just draw a straight chain. 1, 2, 3, 4, 5. 5 carbon and 12 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is the first option that you guys will always have. This is the first isomer that you can draw for every molecule. Just draw it like a straight chain. Okay, now what else can we do? Look at the 3 options. We can have chain isomerism. Let me explain chain isomerism first. In chain isomerism, you have a straight line over here, right? I can simply, for example, I can take off over here I have the CH3. So I can take off one of the carbon atoms from the side and I can make a branch. I can take this carbon atom from the side and I can attach it somewhere in the middle. So now I have taken my straight chain and I have made a branch out of it. That's always possibility number one, because oftentimes when you're solving questions, they'll say make isomers of the following molecule. And at that time, students tend to get confused that, Miss, how many isomers can we make? So this is how you guys are going to go about it. The first thing you're going to do is you're going to say, okay, first possibility is let's try to make it a branch isomer. What can we do? Let's take off one of these chains. Let's take off one of the terminal carbon atoms. Let's take off one of the carbon atoms towards the end and put them somewhere in the middle and see what we get. Okay. So you'll probably get something like this. So 1, 2, 3. Now I can take this last carbon atom and I need to put it somewhere in the middle, not towards the end. I can't put it over here. No. Okay. And I'll explain why. I'll explain why I can't put it over here. Okay. It has to be somewhere in the middle. So I can put it over here. Right. And then we draw the remaining hydrogen. So over here, I've written down CH3 because this is one carbon with 3 hydrogen. And then I have to draw 12 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. You have drawn another possible isomer, right? So what did you do over here? You did chain isomerism. You made a chain out of it. You took a straight chain. You basically made a side chain, right? This was in a straight line. You went ahead and you made a side chain. You attached a branch to it. Again, the number of carbon atoms are the same, the number of hydrogen atoms are the same, but the structure is now different. This is known as your chain isomerism. Okay? Then I can do one more thing. What's the second thing I can do? Let's try to make more isomers out of this. Another possibility that I have is that I can take this CH3, I can take this CH3, and what if I take this terminal carbon atom and also put it somewhere in the middle? Why don't I try doing that? Let's see what we get. Okay. So again, 1, 2, 3. Okay. I'm not drawing this one because this one is going to come towards the middle. Okay. We're moving this. So I'll draw everything as it is. Now, I will take this carbon atom that is towards the side and put it in the middle. And now I will draw the remaining hydrogen atoms. So we can need to have 12 hydrogen atoms. 3, 6, 7, 8, 9, 10, 11, 12. So from this one molecule, I can make 3 possible isomers. And all of these isomers I made by using the concept of chain isomerism. The other ones are not possible over here, but just by using chain isomers, I managed to make 3 possible isomers. Okay. And all I did was I took the terminal carbon atom and I decided to shift them towards the middle. I decided to take the straight chain and make it into a branch. Okay. Now, making sense so far? Any part that's not clear to anybody? Shreya, Viraj, is everything all clear?
Yeah.
Okay. Now, so this is a 3 possible isomers that I can make. Let me put a question in front of you guys, or you guys, let me ask you. Do you guys remember I said that we cannot, for example, when I was making the first isomer, okay, this one, I said we have to put it somewhere in the middle. I cannot put it towards the edge, right? If I did something like that, what if I did something like this? If I did something like this, now you can say, Miss, but the number of carbons are the same, the number of hydrogens are the same, but, but, why is this not an isomer? You can ask me that, right? Miss, but the number of carbons are the same, the number of hydrogens are the same, the structure is different. That's what you told us. You said that if the structure is different, but the number of atoms are the same, it's an isomer. So why can't this be an isomer? What's the logic behind that? Now, how are you guys going to know that you have drawn the correct isomer? Whenever you draw an isomer, always try to name the isomer. What is the name of the isomer? Okay. Now, when we talk about naming of the isomer, so whenever you are going to name the isomer, remember this. The name should be different. If ever you guys are in the exam and you draw two isomers, and when you try to name them, they both are getting the same name, that means you are doing something wrong. Okay? I am going to elaborate on this. Let's talk about how are you guys going to name organic compounds. Okay? Now, when we talk about naming of organic compounds, so the naming of organic compounds, okay. So when we talk about the naming of organic compounds, there are a few rules that you have to remember. Okay. What are the few rules that you have to go ahead and you have to remember? The few rules that you have to remember are every organic compound, okay? Its name can be divided into three parts. A middle part, okay? Then we can have a prefix, and then we can have a suffix, okay? So every organic compound, it is going to have a prefix. It's going to have main, the main name, and it's going to have a suffix, okay? Now, what are you going to write down in the main? In the main name, you're going to write down the number of carbon atoms. Okay. What are you going to write down in the suffix? In the suffix, you'll write down the name of the functional group. I'll explain that in just a second. And what are you going to write down in the prefix? In the prefix, you'll write down any side groups or any extra groups that might be present. Okay. Now, when we are talking about the main name, okay, the main name is always going to be the number of carbon atoms. So when we talk about the number of carbon atoms, remember this. If the compound has one carbon atom, okay, we use the term meth. If it has two carbon atoms, we use the term eth or eth. If it has got three carbon atoms, you will use the word prop. If it has got four carbon atoms, you will use the term but. If it has got five carbon atoms, you will use the term pent. If it has got six carbon atoms, you will use the term hex. If it has got seven carbon atoms, you will use the term hept. If it has got eight carbon atoms, you'll use the term oct. If it's got nine carbon atoms, you'll use the term non. And if it's got 10 carbon atoms, you use the term dec. Okay? So the main name is going to depend upon how many carbon atoms are in your molecule. Okay? After that, you need to look at the functional group. In your syllabus, you have got a few functional groups to study. Okay? Now, the first possibility is alkene. Okay? Alkanes basically have a single covalent bond. Okay? They will have a single covalent bond. Throughout the molecule, they will just have a single covalent bond. That's it. They're not going to have anything else. They will only have carbon They will have carbon and hydrogen only. That's it. Okay. That is known as alkene. If the molecule has the functional group of alkanes, we use the word A and E. Okay, we use the term A and E. So that means, for example, if we have one carbon atom and it's an alkane, so we make it methane. Okay, if we have 6 carbon atoms and it's an alkane, so it becomes a hexane. Okay, then the second functional group you guys have to study are alkenes. Alkenes also have carbon and hydrogen only, but they have a double covalent bond between the carbon atoms. So between the carbon atoms, they will have a double covalent bond. By the way, don't worry about any of these functional groups. We are going to literally have one like whole topic on each functional group that we're going to study. And so we can have alkenes. Whenever you see that the functional group is alkene, you will use the suffix ene. Okay. So for example, if you see that it is a alkene, but it has one carbon atom, so it becomes methane. If it's got 2 carbon atoms, it becomes ethene. If it's an alkene with 3 carbon atoms, it becomes propene, right? Like that. Then the third functional group that you guys need to know about are alcohols. Okay. When we talk about alcohols have a OH group. Okay. So attached to the carbon atom, attached to the carbon atom, you guys will see that it has the OH group, right? If it has an OH group, then what is the functional group? What is the category? It is a alcohol. For alcohol, the suffix is ol, ol, all. Okay? What does that mean? That means that if I have an alcohol with one carbon atom, it's methanol. Okay? If I have a 2 carbon atom alcohol, I will call it ethanol. If I have a 7 carbon atom, I will call it heptanol. If I have a 10 carbon atom alcohol, I will call it decanol. Okay? Then the fourth one that you guys need to know about are your carboxylic acids. Okay? Carboxylic acids have a very special functional group which is known as COOH. Okay? COOH. And don't worry about, actually, if you guys just get the first 3 for now, that is good enough. For the carboxylic acid, we will study, it's not, you don't see a lot of questions related to isomers on this, okay? But we are going to study this whole chapter later on. So if you guys understand alkanes, alkenes, and alcohols for now, just like what the functional group is and how to name it, that's enough, okay? Carboxylic acid, if you guys get it, fine. If you guys don't understand it, don't worry. We have a whole chapter on this, so this will make a bit more sense. But you guys will see that it has attached to the carbon atom. Attached to the carbon atom, you guys will see that there is going to be a group COOH. Okay. If it has a COOH group, it is a carboxylic. And the suffix for a carboxylic acid is oic acid, meaning that if I have one carbon atom, so it becomes methanoic acid. If it has 2 carbon atoms, it becomes ethanoic acid, propanoic acid, butanoic acid, so on and so forth. Okay. Now, this is your functional group. Then we have side groups. So side groups, when we talk about the side groups, in the prefix, okay? In the prefix, we will include the side groups. What are the side groups? For example, we have chlorine, or we have bromine, or we have iodine, right? Or we can have methyl. So methyl group would be, met means one, right? So if I have, for example, and if I have CH3, one carbon with 3 hydrogen. So that's methyl, right? We can have methyl, which would be C2H5. And forget about that. So we can have anything so this is the functional group. And other than the functional group, you have any other group present. Some chlorine, some bromine, some iodine, some phosphorus, doesn't matter. Anything other than the functional group is going to come in the prefix. Okay. In the prefix, we also write down the number of side groups. Okay. So for example, if a molecule has got 2 chlorines, so we will mention that there are 2 chlorines. Okay. And we also write down the location. Now, don't get confused. I am going to make this make sense. All of these rules are going to make sense in just a second. Okay. Let's go around naming our compounds. Now, rule number 1, what are you guys going to do? Always start by naming the main chain. The main chain is the number of carbon atoms. Okay. When you are trying to figure out the number of carbon atoms, always first take a look at the longest continuous chain. What is the longest continuous chain that you guys can make? That's your mean chain. Okay. So for example, if I start from this carbon atom, okay, if I start from this carbon atom, what is the longest chain I can make that is continuous without interruption, without lifting my pen? What is the longest chain I can make? The longest chain I can make is of 5 carbon atoms. So for 5, we always write down pens. So you'll write down pens. Then you guys are going to name the functional group. The functional group over here, we only have carbon and hydrogen and only single covalent bonds. So this is an alkane. So you write down pentane. Now, let's go on to the second one. Okay, let's try to name the second one. And I want you guys to do this with me. Now, if I ask you guys to draw the longest continuous chain, how many carbon atoms do you guys think? How many carbon atoms can I have in my longest continuous chain? So if I make a long continuous chain, I can either make it like this or I can make it like this, right? Two possibilities. Either I can connect the carbon atoms. So remember this, you are making a continuous line. You're connecting the carbon atoms with each other continuously without lifting your pen. So you can make a line like this, or you can make a line like this, right? Two possibilities, two ways, right? Regardless of which method you choose, you are getting 4 carbon atoms. It doesn't matter. If you try to connect the carbon atoms without lifting your pen in one continuous line, in one straight line, you can't do any diagonals. In one straight line, the maximum number of carbon atoms you're getting are 4. Okay? Whenever we have 4, we use the term but. Okay? So you are going to write down but. After that, we'll take a look at the we will take a look at the functional group. The functional group is alkane because we only have carbon and hydrogen and we only have single bonds. So this is going to be butane, right? Now, but in this situation, we also have a side group. Can you see that we have a side group present? This one. We have not mentioned this side group anywhere. We have not included this side group anywhere. So what am I going to do? Now I have to mention the side group. This side group is going to be known as methyl because it only has one carbon atom. Okay. So the side group is going to be known as methyl. So you write down methyl. Okay. Now, you also have to mention the location. Where is this methyl located? How are you going to mention the location? You'll write down the number of carbon atom. Okay. Now, when we talk about the number of carbon atom, whenever you guys are solving questions, number the carbon atoms first from the left hand side and then from the right hand side. Okay. Let's start from the left hand side. If I start from the left hand side, this is carbon number 1. This is carbon number 2. This is carbon number 3. And this is carbon number 4. Okay. If I do the numbering from the right hand side, this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. Okay, so if you see if I number the carbon atoms from the left hand side, we are getting carbon atom number 3. If I number it from the right hand side, we get carbon atom number 2. We always choose the smallest number. Okay, so in this case, I will choose number 2. We always choose the smallest number. So I will write down 2-methyl butane. What is this name telling me? This name is telling me that we have an alkane. Functional group is alkane. That alkane has got 4 carbon atoms. Attached to the 4 carbon atoms, we have a side chain that will be methyl side chain. And that side chain is located on carbon atom number 2. Right? Now, let's try this one. This one, I want you guys to try with me. Both of you, Viraj and Shreya. I want you guys to try this with me. Now, tell me, what is the longest carbon chain I can make? Like if I make if I connect the carbon atoms uninterrupted without lifting my pen, what is the maximum number of carbon atoms I can like make in a chain, in a straight line?
Three. Three.
3, right? Exactly. So if I make it like this, I get 3 carbon atoms. If I decide to make it like this, I still get 3 carbon atoms. And if I make it like this, I still get 3 carbon atoms. Okay. So the main chain, the maximum number I can make is 3. So for 3, what is the term that we use? What term do we use when we have 3 carbon atoms?
Propane.
Prop. Yes, you're correct. This is prop. Okay. And since this is an alkane, so we will write down ene. So we get propane. Now, do you see the side chain? What side chain is given to me? What is the side chain given? I have 2 side chains. Can you guys tell me
Methyl.
what is methyl? Absolutely correct. CH3, I told you guys, CH3 is known as methyl. But over here, I have got 2 side chains. I've got 2 methyl. Okay. So we use the word dimethyl. Dimethyl means that there are 2 methyl groups. And the last thing we have to do is we have to write down the number. So 1, 2, 3. First, always write down the number from both the side, left hand side and right hand side, and then choose 1, 2, 3. So in this case, whether you count from the left hand side or the right hand side, you will get the number 2. So you write down 2, 2, 2. You write down 2, 2. 2, 2 means that, 2, 2 dimethyl propane. What does the name tell me? The name tells me that this is got 3 carbon atoms. It is an alkane. It has a methyl side group, but it has got 2 methyl side groups. And both of those groups are located on carbon number 2, right? Now, look at this isomer that we drew, right? Now, this isomer that we drew, if I ask you guys to name it, how will you name it? What is the longest continuous chain that I can make? What do you guys think? What is the longest continuous chain that I can make over here in this example?
5.
5, right? So this is going to be pent. And this is an alkane, so pentane. So look, so this is what I meant, right? Whenever you are drawing the isomer, you have to try to name it. When you look at the structure, it looks like, if you guys just look at the structure, it will look like this is different and this is different. But when you try to name it, they're both getting the same name. So keep in mind that isomers always have different name. Okay, so if you're ever in the exam and you're confused whether you've drawn the correct isomer or not, always try to name it. Okay, if you get a different name, know that you have drawn it correctly. Now let me give you guys a let's solve a let's go over an example together. Okay. I'm going to give you guys an question. C6, H14. I want you guys to try to make as many isomers of this. I want you guys to go turn by turn. You guys, I'm giving you guys 2 minutes. Okay. Try to think of what are the different isomers that we can draw. We're also going to practice naming the isomers. Okay. So I want you guys to go one by one. Take 2 minutes to figure out. You don't have to get all the isomers, just whatever you guys can figure out. Okay. So go ahead, take 2 minutes, try to figure out as many isomers as you can, and then let's start turn by turn. All right, let's go ahead and now discuss how we can draw the isomers of this. Now, keep in mind, we're just discussing, okay? So whatever ideas you guys have, just throw them at. If you guys are confused about why this is not an isomer, why can't we do it like this, ask me, okay? Because we need to make sure these concepts are completely clear. This is a very basic topic in organic chemistry. You guys understand this now. This is going to help you guys in your A levels. Trust me, you guys will, this naming of the compounds and all, it's going to make your A levels so much easier for you guys as well. So uh just whatever isomer you guys think is possible, say this is possible. You don't understand why it can't be this, you don't understand why it is like this, it's confusing, it's not making sense, ask. Okay, now let's go ahead. Who wants to start off? Who is going to tell me one possible isomer that we can make? If you guys want, you can annotate on the screen, right? you go ahead. If it's easier for you guys to draw it on a piece of paper and send it to me on WhatsApp, you can do that. Whatever is easy for you guys. If you are confused, you can also tell me that I'm thinking of doing it like this and this, and I'll go over it with you. Who's going to tell me who wants to start off? Who's going to give me the first possible isomer that I can make of this molecule?
So can I start?
Viraj, you want to go ahead and start us off?
Okay. There. That's one isomer there.
One isomer, perfect. And can you try to name it, please?
Hexane.
Yes. So first thing you're going to take a look at is the longest possible carbon chain. So this is your longest possible carbon chain with 6 carbon atoms. Okay. 6 carbon atoms means that we're going to use hex.
Mhm.
Oops. We're going to use hex, and this is an alkane, so we write down hex. Perfect. Shreya, can you think of an isomer?
I actually thought about the same one he did. Like,
Okay. Yeah.
Oh, I see. I see. I see.
Yeah. All right. The one Viraj is drawn. Okay. You and me, let's try to brainstorm another one. Think of, remember this. What did I tell you? Whenever we have an isomer, like a straight chain, we can always take off one of the carbon atoms from the sides and put it somewhere in the middle, right? So let's try doing that. Let's try taking one of the carbon atoms off from the side, okay? And let's try putting it somewhere in the middle. Let's take this carbon atom. You and me, we're going to do this together, Shreya, okay? So we're going to take this carbon atom and you are going to put it somewhere in the middle. Remember, this middle means do not put it towards the edges, always put it somewhere in the middle. So why don't you take this, can you annotate on the screen, Shreya? Is it possible for you?
yeah, I think so. Yeah.
Okay, so try this. Take this CH3 from the edge and try putting it somewhere in the middle. Up to you, wherever you want to put it.
Um. Oh wait, 1 second.
Take your time. Don't worry about anything. You can take your time. If you can annotate on the screen, you can annotate. You can draw
Yeah.
it on a paper, whatever you like.
So if you move 1C like
Yes,
to the middle, there'll be only like a chain
yes,
of C, like 5C.
yes. You are right. You want me to draw it for you?
Yeah. Yeah.
All right, I'll draw it for you. So I will draw 1, 2, 3, 4, 5. Okay. And now I can take this CH3 and I can put it somewhere in the middle. Okay. So for now, let's put it over here. And then I will draw the rest of the hydrogen atoms. Can you try naming this, Shreya? Viraj, both of you, try to name this. First, tell me what is the longest continuous chain that I can make. What do you think, Shreya? What is the longest continuous chain that I can make?
It's 5. No,
Yes.
oh, okay.
Yeah, it's 5. The longest continuous chain that I can make is 5. Okay. So one chain that I can make is like this, in which case I get 5. I can also make a chain like this with 4 carbon atoms, but then that's not the longest. Okay. It has to be the longest possible chain. So the longest possible chain that I can make is 5. Now, what is the term that we use for 5? Like, what word do we use?
Pent.
Here, I'll open this. We were here. Look at this table. So when we have 5 carbon atoms, what word should I use?
Pent.
Pent, right? So I'm going to write down pent. Perfect. Then you are going to take a look at the functional group, possible functional group. Okay. So what functional group is this? It is carbon atoms. You only have carbon and hydrogen atoms with single covalent bond. So look over here. Identify the functional group and tell me what should be the suffix. Pent what? Pentane, pentene, pentanol. What should I write down?
Is it pentene?
Yeah, it's pentane, right? The first one, alkanes. In alkenes, we have a double covalent bond. So over here, we don't have any double bonds. If you look at the structure, they're only single bonds, right? So this is an alkane. For an alkane, we write down pentane. Now, after that, you have to identify the side chain. So there's only one side chain that is present, CH3. Okay? So, what is the word that we use for CH3? If you want to look here, you can look here, over here, where I've written down the prefix. What word do we use for CH3? What's the word?
Methyl. Methyl.
Methyl. Exactly. So we have one CH3 that is a side chain. So we write down methyl. Perfectly. Perfect. And now let's try to number it. Okay. You will, when you're numbering it, Shreya, you will write down the numbers first from the left-hand side and then from the right. So 1, 2, 3, 4, 5. And now we write down the numbers from the right-hand side. 1, 2, 3, 4, 5. You will always choose the smallest number. But in this case, in this particular case, we don't have to worry about that. Okay? Because from the right hand side and also from the left hand side, the CH3 group is on carbon number 3, right? Can you see that? That the CH3 group, if I count from the left, I also get carbon number 3. If I count from the right, I also get carbon number 3. Can you see that, Shreya?
Oh, yeah.
So you will write down 3-methyl pentane. Okay. What is the name telling you? The name is telling you that you have an alkane with 5 carbon atoms. Then you have to add a methyl side chain. So CH3 is methyl. And on which carbon atom? On the carbon atom number 3. Okay. This is one possible isomer. Well done. Okay. Viraj, now can you think of another isomer that we can draw?
Yeah.
Go on.
Uh,
Good job. Well done. This is correct. Can you try to name it?
Okay.
Start by Viraj identifying first of all the longest carbon chain. Go ahead. Yeah. Mm-hmm. This is butane. You are correct. The longest carbon chain is 4 carbon atoms, and this is an alkane. So you write down butane. Perfect. Then identify your side chains.
There are two, right? So like, so if there are two side chains,
There are
what can it be then? Methyl?
Okay.
No, they are
Yeah, it is
dimethyl.
dimethyl, exactly. So you're going to write down methyl. The name of the side chain is methyl, and you have 2 side chains, so it becomes dimethyl. If you have 3 side chains, it will become trimethyl, right? You just increase the number, that's it. Right.
Right,
And the
one,
last
two.
thing you have to add is the location. So you'll count
Yeah.
from the left-hand side and also from the right-hand side. You are correct. If you count from the left-hand side, you get 1, 2, 3, 4. And if you count from the right-hand side, you get 1, 2, 3, 4. Okay? So from the left-hand side, you get 2. From the right-hand side, from the left-hand side, you'll get 2. From the right-hand side, you get 3. We always choose the smaller number. So we'll choose 2. So you get 2 dimethyl butane. You are correct. Shreya, making sense how we name this particular isomer?
Yeah.
Okay. Now, can you think of another possible isomer that we can make? I will tell you what. I'll give you a hint. Shreya, we remember this isomer that you and I just drew?
Yeah.
We can do something with this one. We can make one small change and we can do something with this one. Can you think of something? Something that I can change over here. One small change and we have a whole different isomer.
Um.
Okay. So we have this branch. Okay.
Yeah.
Why don't we try changing the location of the branch? Think of it that way. What if instead of putting it on this carbon atom, we make the same chain, we make the same branch, but on this carbon atom, right? We can do something like that as well. That is also going to be an isomer. You want to try draw? Let's draw it. Let's draw it together and see, right?
Okay.
Okay. So first tell me how many carbon atoms should I draw in a straight chain?
Um. 5.
Yes, absolutely correct. 1, 2, 3, 4, 5. Okay. Now, I will take this CH3 and instead of drawing it in the middle over here, I can draw it over here. Okay?
Yeah.
And now I will draw the remaining hydrogen. Whatever hydrogen is left behind, I will just draw them. Now let's try naming this compound. First of all, why don't you go ahead and tell me what is the longest carbon atom chain, longest continuous carbon atom chain that I can have?
It's 5.
Yes. So when it is 5, what is the term that we use?
It's bent.
It is bent. Absolutely correct. Then we have to decide the functional group. So what functional group is this?
Mm. Is it pentane?
Yes, pentane, you are right. Good job. Now, identify the side chain. What side chain is this?
Methyl?
Methyl, absolutely correct. Now try to number.
Could you repeat that? I couldn't hear you.
Yeah, I said now try to number it. What number should I write down? First, first number it from the left-hand side, then the right-hand side, and then choose the smallest number.
Okay.
This CH3 group, you basically have to tell me on which carbon atom is it located. That's what you have to tell me. So number the carbon atoms first from the left-hand side, then from the right-hand side, and choose the smallest number.
Okay. Will it be 2?
It will be 2. You're absolutely correct. Good job. This is going to be 2-methyl pentane, right? So you can see that now if you look at the naming, see the naming was quite similar. Methyl pentane. But the number has changed. You now have a different number. Now, the good thing is that there's just one more isomer that we can possibly make of this. Okay, so what we are going to do is that we're going to stop it over here for today. There's one more possible isomer that's slightly tricky to figure out. I'm giving it to you guys as homework. Okay, we have made,
I had a question.
yes, Viraj, go on.
So, miss, can I draw an isomer over here? Like, I don't know
Yeah,
how to
go on.
name it.
Go on, do it. Okay, Viraj, one thing I just want to add, the isomer that you drew over here, this one, okay? When you are numbering it, you'll write down 2, 2 because they're 2-methyl, right? They're 2-methyl. And both of them are on carbon number 2. So you'll write down 2, 2, okay? To show that both of the methyl are on carbon number 2. But yeah, other than that, go on. Go draw.
So, miss, it's related to the
Yeah,
isomer that I drew. Like,
Yes, go
you
on.
know, okay, wait, so let me just try that. So, miss, how do I name this?
Very good question. I'll tell you exactly how you name it. Okay. So the way you name this is, first of all, you're going to, let's follow the initial rules are the same. Okay. You'll decide on the longest carbon chain. The longest carbon chain is 4 carbon atoms. So you're going to write down bute. It is an alkene. So you write down butane. You have got 2 methyl groups, 1 and 2. Okay. So you will write down, what is the side chain? The side chain is methyl. And you have 2 methyl chains. So you'll write down dimethyl. So far, the naming is exactly the same. Now, when you are numbering it, you are first going to number from the left-hand side and also from the right-hand side. So this becomes 1, 2. This becomes 1, 2, 3, 4. And then you'll count from the right-hand side. So this becomes 1, 2, 3, 4. Now, depending upon the right-hand side, so if you look now over here, when you are numbering it, remember this, that in situations like this, where you have got 2 side chains, okay? And they are on different carbon atoms. So over here, they were on the same carbon atom, there was no problem. But whenever you have side chains that are on different carbon atoms, in this particular case, you will choose either the right-hand side or the left-hand side. Now this is up to you. You will decide, Viraj, whether you want to choose the right-hand side for numbering or whether you want to choose the left-hand side for numbering. Okay? So what you are going to go ahead and do is that if you decide to choose the left-hand side, okay, in that case, you will only number from the left-hand side. Then you're not going to look at the right-hand side, okay? So from the left-hand side, this is going to be 2, 3, right? From the left-hand side, this is carbon atom number 2. From the left-hand side, this is carbon atom number 2. and this is carbon atom number 3. So when you're numbering it, you are going to number it 2, 3 dimethyl butane. Okay, that's how you'll number it. 2, 3 dimethyl butane. Or you can choose to count it from the right hand side. Even if you choose to count it from the right hand side, this becomes carbon atom number 2. This becomes carbon atom number 3. Okay, so the numbering will remain the same. 2, 3 dimethyl butane. So in situations like these where you have more than one side chain, okay, they're on different carbon atoms. So you can count from the right side or the left side. But remember this, if you choose to count from the right side, then all of the groups have to be numbered from the right hand side. If you choose the left side, then you have to choose the numbering of the left side for all of the groups. Okay. So I can't do this 3 and 3. No. If I have chosen to count from the left hand side, then I will number all of them based on the left hand side. So this is 2, this is 3. Right? Making sense?
Yes.
Okay, great. And by the way, this is also correct isomer. Good job, Viraj. Other than this, there is also one possible isomer that we can draw. Okay, there is one more isomer that we can make, and that I'm giving to both of you as a homework. It's slightly complex, tricky to figure out. Okay, so I'm giving that to you as a homework. I want you guys to figure out what is one more possible isomer that I can draw of hexane. All right. Now, we're going to go ahead. We're going to stop it over here for today. In our next class, we're going to pick up from where we left off, okay? We are going to go over more isomers. We're going to go over practice questions, and we are going to discuss isomerism and naming of the compounds and what kind of questions you get in your exams. Okay, guys? Okay, all right. Shreya, is everything clear? Is it making sense? Any part that was not completely clear?
No, I understand everything.
Perfect. All right. Okay, Shreya, then I will see you in the next class. Do try to figure out what this other possible isomer is of this compound. If you want to guys want to take a screenshot, you guys can go ahead take a screenshot. Do try to figure out what is the other possible isomer. Try to go over the naming rules. Try to learn this. It will really help you out. And in the next class, we're going to practice more isomers and more naming of the compounds, and we're going to go over some questions. So try to go over the topic if possible, guys. Okay, all right. Thank you so much, Shreya. I'll see you in the next.